In this video, I'm going to show you how you can use a cheap multimeter to measure resistances in the milliohm range with a decent amount of accuracy. Most of the time, a resistance of a few milliohms doesn't matter. But if there are high currents in your circuit, a few milliohms can cause a substantial voltage drop and power loss in the wires. For example, let's say you're designing a coil gun or winding a solenoid, or you have a project with long battery wires and you want to know the exact resistance of a piece of wire. If you try to use your multimeter's resistance function, you'll get a useless reading. 0 ohms, 0.3 ohms, I have no idea what's going on here. Even a top-of-the-line multimeter will just say something like 0.2 ohms, when I know for sure the resistance is a lot less than that. Part of the problem is that you're measuring the resistance of the multimeter's cables, and part of it is that multimeters are just not designed to measure resistances this small. The solution to the problem is called 4-wire measurement, also sometimes called Kelvin resistance measurement, and it's really simple. Let's start out with a constant current source of 1 amp, and I'm going to show you how to set that up later. Since it's a constant current source, no matter what resistance I connect it to, the current flowing through the circuit will always be exactly 1 amp. Now, let's say I connect an unknown resistance, and let's call that resistance R. And let's connect a multimeter across the resistance and use it to measure the voltage across R, and let's call that voltage V. Ohm's law is volts equals current times resistance, and rearranged, that gives you volts divided by current equals resistance. Now, because we know that I in this circuit is exactly 1 amp, you end up with V equals R. In other words, the resistance in ohms is the same as the number of volts across R. So let's say you measure 50 millivolts across the wire you're testing. That means that the resistance of the wire is 50 milliohms. Here I am measuring the voltage across a small piece of wire, and since the reading is 14 millivolts, I know that the wire has a resistance of 14 milliohms. You will never get this kind of accuracy with the traditional 2-wire measurement approach. Now, another cool thing about this circuit is how the resistances of the test wires and alligator clips are not a big deal anymore. The current is always exactly 1 amp, so as long as I measure the voltage directly across the device under test, I can calculate its resistance. And because the input impedance of the multimeter is so high, well into the mega-ohm range, almost no current flows into the multimeter, so the meter doesn't affect the circuit. Okay, now here's the easiest way to do this in real life. I strongly recommend that you have a bench power supply with current limiting functionality. If you don't have one, you should check out mpja.com. Start out by setting the voltage to about 2 volts. The exact number doesn't matter, but keep it a low voltage because we're going to start short-circuiting things pretty soon. Start with the current limiting dial set to 0. Now connect a multimeter set to measure current directly across the power wires. Now we just need to increase the current limits so that we get exactly 1 amp. Doing this with the multimeter gives you a little more accuracy than just reading the bench supply's display. Okay, now we have a constant current supply of 1 amp, and you just need to connect your current supply wires to the thing you want to measure, then measure the voltage across it. Let's measure the resistance of this inductor. 47 millivolts means the inductor has a DC resistance of 47 milliohms. And this piece of speaker wire has a resistance of 7 milliohms. Okay, now what if you don't have a current limiting power supply like I do? Well, you can build a constant current source out of an LM317 using this circuit. In theory, this should give you a constant current of 1 amp regardless of what you have connected to it. Now, in reality, you'll never find a precise 1.25 ohm power resistor, so the current won't be exactly 1 amp. So here's what you have to do. First, use your multimeter to measure the actual current that you're getting out from the circuit. In my case, I got 0.92 amps. Next, you measure the voltage across your wire as before. Let's say it's 80 millivolts for a certain piece of wire. Now you apply Ohm's law again, but since the current isn't exactly 1 amp, you can't do the easy volts to ohms conversion. Instead, you take your measured voltage, divide it by your measured current, and you'll get the exact resistance of your piece of wire. That's it for 4-wire measurement, and now your death ray designs can be more efficient than ever.